Look at the question that you had a quiz on Friday. This is a pretty tough question. It requires a lot of work, a couple different pieces here. So a rectangular in-ground pool is modeled by the prism below. The inside of the pool is 16 feet wide, 35 feet long, shallow and deep end, slope connecting the two ends. Without water, these are the dimensions and the depths. If it's got an angle of 16.5 degrees, you want to know the depth of the pool at the deep end. Then they want you to find the volume. Then they want you to know, okay, well, a garden hose is filling the pool up, and it comes out at 10.5 gallons per minute. How much to the nearest hour will it take to fill a pool if it's 6 inches from the top? So this is a really tough question. A lot of components. It was the last question on one of the regions for 6 points. So where should we start? Well, let's start at the first thing they're asking us. How do we find the depth of the deep end? Well, if you take a look, the deep end would be all of this. We've already got this part. We just need whatever this is plus 4.5. So we really need like this piece down here, because we already know this is 4.5 here at this area. So the way we can find that is, well, it's this piece plus this piece. So how are we going to find this piece? Well, it's kind of difficult because maybe you wouldn't think about it right away, but we know that there's a right angle here, and they've given us a degree. And we know when we have right triangles and some degree, we can always find sides using SOHCAHTOA or trigonometry. So to be able to get anything here, we need one side. Right now we don't have any sides, but we can definitely get something. And the piece that we can get is this piece right here. And the reason we can get that is because we've got 35 is this whole long piece, which means if I had brought it down here, this would also be 35. So I'm just going to subtract 12.5 and 9 from 35. And what I'm left with is 13.5. I'm left with 13.5. So now what I'm going to do is I'm going to use this 13.5 to figure out what that little black piece is there. And the way I'm going to do that is I'm going to use SOHCAHTOA. I'm going to use my trigonometry. So I do SOHCAHTOA. I see that this is my adjacent and this is my opposite. I'm going to have to use tangent. So I go tangent of 16.5 is equal to x over 13.5. And I hope you guys can see this color yellow. And I end up with x being equal to about 4. So my x is equal to about 4. So this is equal to about 4. So now I just got to do, okay, 4.5 plus 4. Well, that's super easy. That's just 8.5. So for the first answer, you should have gotten 8.5. So depth of the pool, 8.5. Let's put that there so we don't forget. Now they want to know what the volume of the inside is. So this part is actually particularly difficult because you have to decide what shape is this right here. Well, it's a prism, but what's the base, right? So we talked about volume being area of the base times the height. Well, the base in this case is a triangle, right? We've got a triangle on both ends. So that means that I'm stacking triangles up on top of each other. So if I'm stacking triangles, I need the area of a triangle. The area of a triangle is 1/2 base times height, right? So I'm going to have to use 1/2 base times height to figure out this area in here. So let's go ahead and do that, right? So I'm going to have, okay, 13.5 times 4 times 0.5, right? Because that would be 1/2. Times what else, though, right? Times the height, right? So let's take a look. I've got 13.5 times 4, right? This is 13.5. This is 4. I need that height because I'm stacking it up. And that height is actually 16 because it runs parallel to this side, times 16. And because it's a triangle, I wanted to do half that base. So I'm also multiplying it by 1/2 or 0.5. And what this ends up getting me, and my volume will be in red here, is 432 feet cubed. Okay, feet cubed. And that is my volume there, 432. The next piece is an easy piece. It's just this. It's this box right here, this green one that I'm trying to draw in for you now. And how much is this? Well, it's actually just the regular rectangular prism. We just got to do 4.5 times 9 times 16, which gives you 648 feet cubed, cubic feet. I'm not going to write that out. It's just a regular rectangular prism. 16, 4.5, and 9 gives you 648. Okay, now the next piece we're going to do is this kind of invisible piece, right? So we also know that there is a prism here. Between the red stuff and this green stuff, there's a purple prism, and it runs like this, okay? It's inside this purple prism, and we got to figure out what that is. Well, as you can see, 13.5 is the side. This is actually just another rectangular prism. 16 runs along this way, 13.5 runs along this side, and we know that this height is 4.5 from over there. So now this one, this purple one, is just 4.5 for the height times 13.5 for the length. 13.5 for the length times 16 for the width, and that leaves you with 972. 972. So now we've got 3 areas, and this is feet cubed. 3 areas, 1, 2, 3. We need one more. It's this big area over here. This big area here. Right, and this is the deep end, okay? Ooh, the deep end. So how are we going to figure this out? Again, it's just a rectangular prism. I know this is 16, this is 8.5, this is 12.5. I'm just going to multiply those guys together, and you end up with 1,700 cubic feet. When you're done, you have to add this, plus this, plus this, plus this, all the areas together, and you get, all the volumes together, and you get a volume of the pool, which is 3,752 cubic feet. Okay, and this is your volume for the pool. So we've done this. We got the depth, 8.5. We've got the volume, 3,752. Now we're saying a garden hose is used to fill the pool. Water comes out at a rate of 10.5 gallons per minute. How much time to the nearest hour will it take to fill from 6 inches from the top? So this says that, okay, well, water's going in there at 10.5 gallons per minute, and about 7.48 gallons fit in 1 cubic foot of volume. But they're asking us for volume for 6 inches from the top. So what I'm going to have to do is I'm going to take this volume, and I'm going to have to divide out 6 inches from the top. So that's pretty easy, actually, because it's just going to be this volume, right, minus whatever 6 inches from the top would be, right? So I'm going to do 35, because I know my length is 35, times 16, because that's going to be my width for the whole pool. And this is in feet, okay? Remember, this is in feet. So they said 6 inches, but instead of using 6 inches, I'm going to be using half of a foot, right? So this is half of a foot, because I don't want it in inches. I want it in feet. So 6 inches, half of 12 is 6, so this is half of a foot. And then that would be equal to 3,472. So now this is the volume 6 inches from the top. Now I'm going to do my stuff with the gallons. So here I need to see, well, how many gallons are there going to be? Well, I know for one of them it's 7.848 gallons. So I'm going to multiply it by how many gallons, how many cubic feet I have, and I end up with 2597 and 1. So 25,971. And this is how many gallons I'm going to have, right? Because I'm multiplying, I'm now changing the volume to gallons because I want to know gallons. And this says gallons per minute. So what you got to do is divide this by 60 because we want to know how many minutes there are. And it comes out to an average of 41 hours. I'm sorry, I said we want to divide it by 60 because this is currently in minutes, right? This is currently in minutes. We want it in hours, so there are 60 minutes in 1 hour. We've got to divide it by 60. 41 hours. That was a tough question. It had a lot of components. If you got it right, congrats. You're pretty much a master at volume. We're going to have some more tough questions with density coming up that also involve volume. So stay on your game. Please like and subscribe, and have a good one.